Data access architecture makes every data request prove what it is allowed to see. For AI, that means protecting fields, rows, classified content, and final responses, because sensitive data can leak through retrieval, summaries, citations, or generated answers. We've built the foundation: identity, application, data, cloud, workload, and governance controls. Now we narrow the focus to the data itself, what AI systems may retrieve, process, reveal, or filter based on policy. Data access is a chain of decisions, not a single permission. First, identify who is asking, what role they have, and why they need the data. Then apply policy: least privilege, need to know, purpose limitation, classification, and context. Those decisions must follow the request across databases, APIs, data lakes, vector stores, and AI retrieval. In AI, failure may not look like a denied query. It may show up as leakage, over-retrieval, unsafe summaries, or exposed citations. Access control also depends on a chain of responsibilities. The policy information point supplies facts: who the user is, their department, clearance, tenant, device posture, and the data's classification. The policy decision point evaluates those facts against rules and returns a decision. Policy enforcement points then act on that decision at the gateway, API, database, search index, vector store, or AI response filter. Strong designs enforce repeatedly, so one missed checkpoint does not expose sensitive data. Column-level security protects the most sensitive fields without hiding the entire record. A support user might need a customer's name and case notes, but not their social security number or account balance. Finance may see balances, compliance may see regulated identifiers, and an AI assistant may receive only masked or tokenized values. The key is consistent enforcement everywhere data travels: queries, dashboards, exports, APIs, logs, and model context windows. Those column controls cannot stop at the source database. As data moves through ETL, feature engineering, dashboards, embeddings, and model prompts, the same restrictions must travel with it. Mask or tokenize sensitive fields before export, logging, embedding, or retrieval. Watch derived features as well. A protected attribute can reappear indirectly through transformations. The safest pattern is minimization. Give each pipeline stage and each AI request only the columns it is authorized to use. Row-level security answers a different question from field masking. Not which columns can this person see, but which records belong in their context. A tenant user gets tenant records, a project worker gets assigned project records, a regional manager gets only their region. Enforce that rule near the data source, so applications, dashboards, APIs, and AI retrieval inherit the same boundary and cannot accidentally pull records from outside scope. This is where authorization becomes data-specific. It is not enough to know who the user is. Every query must ask which records they are allowed to see. In a multi-tenant support assistant, tenant A must never retrieve tenant B's tickets, even through search, analytics, or AI context. The same pattern applies to departments, assigned owners, and clearance levels. The safest design puts these filters in shared policy enforcement, not scattered application code. In RAG, row-level security cannot stop at the source database. Once documents become chunks and embeddings, the authorization context has to move with them: tenant, owner, project, region, classification, and access group. The critical control happens before retrieval results reach the orchestrator. Vector search should filter by the user's entitlements first, then rank and return content. If you search first and filter later, unauthorized text can leak through snippets, logs, citations, or prompt context. Classification becomes powerful when labels are treated as enforceable metadata, not just human-readable tags. A label like confidential or regulated should travel with the data into catalogs, APIs, databases, and AI workflows. Policy engines can then translate that label into controls: who may access it, whether encryption is required, which DLP rules apply, how long it is retained, and whether an AI system may retrieve, summarize, or expose it. Here's what that looks like in practice. A public dataset might be searchable and summarized freely. Internal data requires enterprise sign-in and may block external AI tools. Confidential data adds justification, encryption, logging, and export limits. Restricted or regulated data gets the strongest controls. Explicit approval, DLP, retention rules, audit trails, and often no AI retrieval unless it is specifically approved. Preventing unauthorized disclosure has to continue after retrieval. The system first limits context to the documents, rows, chunks, and fields the user may access. Metadata checks tenant, clearance, labels, and purpose before anything reaches the prompt. During generation, sensitive values can still surface, so output policy checks redact or transform them. Finally, citations are validated so references do not expose restricted source names, snippets, or metadata. Security applies end-to-end. Strong AI access control starts before content reaches the prompt. Filter candidate content by tenant, project, role, classification, consent, residency, ownership, and purpose. Then treat metadata as a security boundary. It must be complete, trusted, consistent, and protected from tampering. Finally, validate citations and outputs. If a source is unauthorized, the system should not cite it, hint at it, or quote it. The safe answer is a clear denial, not a workaround. Controls are only trustworthy if you test them against real failure modes. Use different roles and agents to prove column restrictions work. Challenge row policies across tenants, projects, regions, and ownership boundaries. Validate classification rules by attempting blocked exports, retrievals, summaries, and retention exceptions. Then monitor continuously. Denied requests, unusual retrieval volume, bypass attempts, redaction events, and anomalous AI responses. Testing turns access design into measurable assurance. Data access architecture is the bridge from identity governance to secure AI behavior. Column controls protect fields, row filters limit records and chunks, classification rules define handling, and response controls decide what AI may reveal. Next, we extend these ideas to AI access, privileged operations, monitoring, and the capstone.